Hi everyone and welcome back to the channel. Today I've got something special for you. When I rekindled my passion for astrophotography back in 2020, one of my very first targets, alongside other of course, was the mighty Orion Nebula, also known as Messier 42 or M42. The Orion Nebula is an impressive target. It's a large and relatively bright object in the night sky, making it a fantastic subject for astrophotography. Whether you just started out or you've already got some experience under your belt. However, when it comes to processing images of this nebula, things can get a bit tricky. There are some challenges that make it not so straightforward to edit, but don't worry, I'm here to guide you through it. This is the first of a two-part series where I'll break down every single step of the editing process in detail, using the Orion Nebula as our example. This tutorial is perfect for those of you using DSLR cameras, as well as anyone working with dedicated Astro cameras. I'll show you how to take this stacked version of the Orion Nebula and turn it into this beautiful final version using Pixinsight, along with a few additional plugins. For this project I used a Canon M50 camera with a 15 to 45 mm kit lens. My setup was super simple, just a budget tripod, no filters, no Astro modifications to the camera and no calibration frames. So without further ado, let's dive right in. Alright, let's start this very basic beginner Pixinsight tutorial. What you will first have after image acquisition, most probably using your DSLR as a beginner, is you will have a so-called light frame, or just an image of your object. Maybe a CR3 or CR2 file format. After loading the image, you will see this. And maybe you will wonder, because it's very dark and looks completely different than you expected. This is because the image is still in a raw format or linear state. That means the image has to be stretched first. Before we do anything here, I think this window is much too small to see anything. So right click here and go to zoom to fit, and this makes it a little bigger in relation to your screen size and so on. So now let's zoom in. So we have those three prominent stars of the Orion belt, and let's zoom in here. And this is the region where the Great Orion Nebula is located here. And you can see two main things. First, you have star trails. This is most likely because you selected a exposure time which was too long. That leads to star trails. This image is, I think it's from 2020 or something, when I restarted the hobby, and you can clearly see it's too long exposure time. But you also can see something else which is very important for further processing. You can see two separated stars here. You have star trails, but you have two separated stars. Just keep this in mind. Now let's do the stretching of this image. So first let's zoom out here again, or just right click, zoom to fit. And in Pixinsight you have all the processes you need, or not all, but most of them you will need on a regular basis. Here under all processes, and here you have many functions and crazy stuff here. I will not go into detail, and most probably you will not need all of them, but only a part of them. Okay, so to do a stretching, for example, or to have a preview of a stretched version, you will use a function which is called a screen transfer function. This is that one here, screen transfer function. So just click it. Now new window will pop up, and just click here. Then you have a image selected. We have only one, so this will be applied to this image. You just press this nuke button here. That means auto stretch. That does not mean you your image will be stretched, but you will only get a preview of a stretched image. This is also very important for later processing. Okay, just press it. And this is what I have now. So this is my image from image acquisition, and as you can see here on the left side I have a wall, it's from the house, and here I have some trees. And the object, my object of interest, was going from left to right. So I only had, I think, maybe half an hour or 45 minutes to image this Orion Nebula here. You have those 3 stars. Let's zoom in again a little here. Okay, you have those 3 prominent stars of the Orion belt, and you also have the Orion Nebula here. Let's further zoom in, and now you can see something important here. You still can see, of course, the star trails, but you also can see that the separation of those 2 stars, they are not so well separated as before. And this is because the image has been stretched. Or let's say you have now a preview of an image which is stretched. And this is really important. That means when we do the stretching of this image, we will encounter a problem most probably, because when we will stretch it, this area will be stretched very much. So maybe even so much that you cannot see the separation of the stars anymore. So this is an important point here on this object. So it's quite easy for a beginner to make a photo of the great Orion Nebula and the constellation and so on. This is quite easy because it's very bright stars and a quite bright or very bright nebula here, and it appears to be very large from the Earth. Okay, this is good. The downside is that you have an image, or you have a constellation, let's say, with a high dynamic range. That means you have a very, very bright region here in the core of the Orion Nebula, and what you cannot see now, here's also a nebula. This is called the Flame Nebula. You cannot see it using one image. That's why we already did several images of this object and other objects in the future most probably, because you make a stack of all the images, and this leads to higher signal and lower noise. So after stacking all the 77 images I did, you will also see a faint nebula here. And this is a problem for processing, because that's what I mean with high dynamic range. You have a very, very bright region here. This is easy to overstretch and not to have the separation anymore, and you have a quite faint object or nebula here. Somehow we have to apply different stretching here than here. I will show you how. Okay, first let's zoom to fit again, close this, and this is, as I said, this is a raw image. This has not been stretched now. So this is what we will start with. This is a single image, raw format from a DSLR camera without any modification. So you will start your imaging using your DSLR camera, and you will do many, many photos of this object, for example. In this case, it's 77 single images with 6 seconds exposure time each. So let's stack in Pixinsight. First you go to Script, Batch Processing, Weighted Batch Pre-Processing. This will most probably take some seconds to open, that's normal. And we have our light frames. This is exactly the image you can see here. Later, when you may be more experienced, you can also do flat frames, dark frames and bias frames. They are all some kind of calibration frames. Flat frames remove the vignetting of your image, and darks and bias frames are other calibration frames dealing with noise of your sensor, for example. But this is not of interest in this very basic beginner tutorial. So let's start with only lights. Also for this image and this whole project, I did not do any flat frames, dark frames or bias frames. I was a beginner and that's all I had. And this could also be enough already to get a nice looking image. Okay, so you go to lights, then here you select lights, then you select your folder where you have all your light frames. You select all of them and just open. Okay, and then you will have a list of all your light frames, and as a beginner you don't have to deal with other settings here or something. Just select the output directory. This is important. In my case it's the desktop, and just press run. You will get information how much storage you will need on your computer. In this case it's 42 gigabytes, and we still have plenty left. So this is good. Just press continue and start the process. And now you can see from bottom to top what the script is doing for stacking your images. So it's different steps, it's burying and so on. And at the end it will also do an auto crop. Depending on the amount of pictures and calibration frames and so on, it could take maybe several minutes or even hours, for example. So let's fast forward and go to the actual processing. At the end you will have several new folders here, and you just go to the master folder and will select the last picture or the second last. The last one is usually the cropped version, and you will only select the non-cropped version of your stacked image. And this is the stacked image. If you zoom in again, you can see those three prominent stars of the Orion constellation. And here again you have those separated stars. You can see we still have star trails here, but we also have a better separation now after stacking all the images now. This is very good to zoom to fit. And as I said, you can either use all processes here to have a preview of a stretched image. Let's open the screen transfer function. And what you also can do here is you can take this triangle and just place it here. So you can either apply the screen transfer function or other functions by drag and drop this triangle here to the on top of the image, or you can just press here. But in this case I created a process icon. So let's close this, and if you double click here, now you have the screen transfer function again. So this is kind of a shortcut for all your processes. You can do another one. Let's call it SCNR. I will explain later what it's good for. Just drag and drop again. Close this, double click, and again you have your SCNR. You can also save those by selecting all of them, right click and save selected icons. Most probably you will save it in a bin in Pixinsight's bin folder and just give it a name and save. I will delete this now and this as well, because I already have a list of processes I usually apply. So just right click, go to process icons and load process icons. I have a list already here, just open this one for the Mac. I also do processing on the Windows computer. I also did a YouTube video in the past where I compared processing on a Windows machine versus a Mac. So check it out if you're interested. Okay, let's come back to our processing icons. So now, as you can see, I have a list with different functions, and most of them you can find in process or processes and so on. Two of them are plugins you have to pay for example BlurXTerminator and NoiseXTerminator. And also I have another one which is called Starnet 2, which is a free program to remove stars from your object. I will show you all the advantages for this later. We have our functions, and now we want to see a preview of a stretched version of this image. Just open screen transfer function, STF, and just apply this new button again. And now you can see a stretched version of our stacked image. As you can see, you have a blur here. This is because the image has been stretched and the tree, for example, was moving and so on. Maybe I also moved the camera here. I don't remember. So let's zoom in here. And what you can see now, we still, after applying this screen transfer function to see a preview of a stretched image, we can still this separation here in the core section of the Orion Nebula. You also get an idea about the nebulosity here, and this is important when doing your imaging. Please do one photo and check if you can see star trails. If they are too prominent, I would really reduce the exposure time. In this case, it was a beginner mistake. It's maybe 4 or 5 years old, but we can still reduce this a little bit. But I would not recommend to do this when imaging. So yeah, let's zoom in here. You can still see there's no indication for a second nebula here, but there's one. We will see later. Let's zoom to fit again. And first thing you would do here is to crop this image. And this you will do by dynamic crop. That's a function, process, all processes, dynamic crop. Here. And let's do a cropping. Let's zoom out a little, crop this image. I would do like this. In this case, maybe you can have a stripe here, but I would really reduce it to this area of the constellation, of the main or part of this constellation, maybe like this. Click this check mark here. Now we have a cropped version. Close this, right click, zoom to fit. So this is actually quite nice, but the contrast is quite low. The first thing you will most probably do is some kind of background extraction. For the dynamic background extraction, you need to place several sample squares here, and this could be a quite long process. So in this case, I would just try the automatic background extraction. You will not change any of those settings. You just go to target image correction, select subtraction, and also select discard background model. Just apply this by drag and drop this triangle here. Wait a few seconds, and now close this again, and now you would maybe wonder, because this is really dark and this is so bright, the color changed the appearance of this image, and it did the preview of the de-stretching again. So let's apply the screen transfer function again. Just press this new button again. Now it will really look different. This is before automatic background extraction, and this is after. Maybe you will say, okay, now I have this strange gradient here, I have this one, and this was already inside this image, but you could not see it. Another thing which is very nice, so now you have a higher contrast here. For example, let's zoom in here again. And one nice thing, if you want to see exactly the same position in your image as your reference image, just drag and drop this here on top of this identifier, and you will see exactly the same position. We have a higher contrast here. We can see much more of the nebulosity, but the noise is much more visible here. Due to the automatic background extraction, the stretching was applied more aggressively, but you can see more nebulosity here. If you just go to the exact same position of this image and zoom out a little, you can see that you now have a hint of another nebula here, and you cannot see it here. All in all, background extraction is really crucial. It will strongly improve the contrast of your image. This you can crop later anyways, but so far so good. Now let's minimize this, and let's work on this one here. Okay, now what? First thing you will do after background extraction is reducing the noise. As I said before, this is a preview of a stretched image. This has not yet been stretched, and in this so-called linear state or non-stretched state, it's much more efficient to apply denoising. You can do this using many different tools in Pixinsight, for example using TGV denoise. This is a very good tool, but I have another one which is called NoiseXTerminator. As I said already, it's a plugin you have to pay for Pixinsight. This is not free, but this is really such an amazing tool and plugin. I highly recommend it because it's really able to strongly reduce your noise and still keeping all the structures and the details of your image. First, the default setting is 0.9. I would always reduce it to 0.6, let's say, and just apply by drag and drop. Wait a few seconds. And isn't this cool? I mean, and now it's strongly reduced. Don't panic, we can still see a lot of noise, but we can deal with this later. I also have to say, when you apply the screen transfer function to see a preview of a stretched version of your image, this stretching values are very aggressive, I would say. It's actually always too high, and this will also lead to the fact that you can see much more noise than you will have in your final image. So let's close this one. The next thing you can do is to improve the colors or the color calibration, for example. You can either do photometric color calibration, or you can even do the spectrophotometric color calibration. If you use specific filters during imaging, you can also select them here, and this will be recognized and applied to the spectrophotometric color calibration. But in this case, I did not use any filters. Another thing which is important for spectrophotometric color calibration is you will also have to have a star catalog. If you just install Pixinsight, it will not have any star catalogs. I already explained all in detail about all the star catalogs and how to install them and download them in my previous video, so check it out. But before we will do the spectrophotometric color calibration, there's one thing to do. Maybe you already heard about plate solving or image solving. That means the algorithm which will apply the colors or the color calibration does not know where you are in the night sky. Plate solving means indication of the position depending on the location of the star and also brightness and so on. To do image solving or plate solving, first just go to Script, Image Analysis, and go to Image Solver. If you did not stack your image in Pixinsight, you will have to fill the data here, the acquisition time and date and so on. Also the focal distance of your scope and so on, and the pixel size. But since I stacked my images in Pixinsight and all the data are in the raw CR3 files, I don't have to fill this, but just click here, search, and this is the Great Orion Nebula or M42 catalog number for this object. Just select one, click OK, and click OK again. And now the image will be solved. Keep in mind that it's really important to install your star catalogs, otherwise it will not work. Okay, now it's ready. It now knows the position of the constellation and this object and so on. And now we can apply the spectrophotometric color calibration. You don't have to do anything here, just apply it. Drag and drop the triangle and wait a few seconds. Now you can close this. You will also get a graph. We are not interested in this at the moment. This is our color calibrated image. This is before, after, before, after. Most probably since the colors changed, you have to reapply the screen transfer function. And this almost looks worse, but keep in mind we will remove all the noise here, and it's all about the colors at the moment. So don't panic. Maybe now it's a point to redo the dynamic crop as before. And just reapply this here. Okay, that's fine. And now let's do the actual stretching of this image. First we have to cancel the screen transfer function preview. Just click here to reset screen transfer function. Okay, now you will go to histogram transformation, and now click here to get a signal peak. It's on the very left side, this graph. And if we would now change anything here, we would not see it here in this picture. And to get a preview, just click on this symbol here. And now we have a preview of the changes we will do here. Just reset the settings again. And this is what we have at the moment, as you can see. And now just take this triangle and move it to the left. And now we can see the image is getting brighter, darker, brighter. To apply this, just click here or press F5. And now you may wonder, this looks different than what we did before. This is because since we did not reset the settings here, this is the preview of a second stretch. To reset the settings, go here, click, and now this is what we already applied to our image. This is a preview, and let's do this again. Apply, reset. Now we can see much more here. To zoom in, just click here. Maybe even more. And now we can still see the separation here of this very bright region. What happens if we go further? Now, this is important. If you go here, so this is our signal peak. We don't want to clip anything here. And then in this case, it would not be the case. So we would not clip any data. So this would be good. But one thing is really crucial here. Now that you stretch the image, you cannot see, or you don't have the separation here of those two stars, or two bright regions, let's say. And this would be already too much. This actually looks quite nice, right? And you can see many details here with regard to this region. But this is really a problem, and this would be too much stretching already in this case. So let's reset and maybe just increase this a little bit. Apply, reset, close. So what can we do now? In this case, after stretching, we can still see the separation, which is very good. But we can still not see this nebula here. So we have to really stretch this region independently from all other parts of this object or of this image. And just go to process, all process, and click range selection. This gives you a range mask. Just go to preview. Now you can see it's all white because we have to change something here. So now in this position, you would only see very bright regions here. Let's zoom in. Okay, and this is the region of interest actually. Let's zoom out again. So you can make more regions visible for stretching. This is very good. But you also can exclude some of them. For example, the brightest part using this slider here, for example. You can also increase the smoothness. This is very nice. So now you only have the brightest region, and this, in this case, it's really the core of the Great Orion Nebula, and we can exclude this now. And now we can exclude this region for stretching. Let's apply. Now we have a mask. If you don't know what a mask is, the brighter regions can be affected, or you can invert the mask and make that the brighter regions, in this case, are not affected from anything you will do. So just apply this here and zoom to fit. Now we have a darker area here, Just invert this. This would mean that all this area is now not so much affected from everything we apply to this image than all the darker regions here. Let's try this. Don't close the mask because then it will not be applied anymore. And to work with this mask without seeing the red color here, just go to mask and show mask, not to show the mask. And now just do the stretching again. Open the preview, maybe, yeah, open this region and do the stretching again. Now you can see at a certain limit, you will have the same again, but now we have a stronger, stretching, and you can still see some separation here. Maybe like this. Let's check this region. Yeah, still some separation, and make this darker using this slider here. Just apply, reset. And now we have a quite nice stretching here. You can now already see some nebulosity here, or some kind of indication for that. And we can still see the separation here and see more nebulosity and have a dark nebula. So far so good. I would not do more stretching here. We can do this later, but so far so good. Close this, remove the mask. We still have it here. We can apply it later or can do a new one. So just leave it here. Most probably after stretching you will see more green color. This is because of the design of the imaging sensor. Just go to SCNR to remove color cast for red, green or blue. Most cases you will need green. Always reduce the value here and just apply by drag and drop. For after, before, after. It's not a major difference, but you will see it later. Just close it. And now let's separate all the stars from the main object. This is very helpful for processing. You can do this, for example, using a paid plugin, which is called StarlessXTerminator, but you also can use a free plugin, which is called StarNet 2. I already did several videos about how to install this in Pixinsight, so check it out. Linear data. Linear data is a non-stretched image. But since we already stretched this image, uncheck this. And we want to have not only a starless image, but we want to have a separate image with the stars and one only with a nebulosity. That's why we click Create Star Mask and just drag and drop this and wait a few seconds. Okay, now it's finished. It's very nice. We have all the stars. We don't have our nebulosity here anymore, and we have an image only with a nebulosity here. Here, for example, now we can see it even better without stars. And here's our nebula, Great Orion Nebula. I think now it's a very good point to make a pause here, and let's switch to the second part. You will find the link for the second part in the video description down below. And that wraps up part 1 of this tutorial. Crazy what you can do with some skills for processing. You think it's only low quality you can get from a cheap DSLR camera, but it's not. It's really not. You can see this. I hope you found it helpful and that you're excited to try editing your own images of the Orion Nebula. If you enjoyed this video, please give it a thumbs up and consider subscribing to my channel for more astrophotography tips and tutorials. Thank you for watching and see you next time in part 2.